Alright, this is Mr. Heath, and what I'm going to do is go over your assessment for tomorrow. There has been a change in the words, so I wanted to make sure we talked about this. I want the dioxin to be in the denominator position, so I put the wording over here so it can be in a proper order, and we'll talk about that. So it says, the team has created an antivenom snake bite antidote. The doctors are creating a mixture that is 4 grams of water for every 1 gram of dioxin. So let's take a look at that. 4 grams of water to every. I wanted the dioxin to be in the numerator, but I set this up incorrect, so I wanted to show you. So a great idea to see this is that 4 grams to every 1. So notice how I have this up this way, 4 grams to every 1, and then turn here, and there we have it. Our traditional wind up where I can find my quotient, which is going to be 4. So that's one way to see these that'll make it play out easier. Alright, so armed with that information, let's go here, set this back, and read the rest. So it says, Dr. Heath and Dr. Lopez antivenom team has created a mixture that is 1 gram of water for every 1/4 grams of dioxin. Dr. Heath and Dr. Lopez have both stated that their ratio of antivenom is just as effective as the other team's antivenom. Your challenge: you and your team has been sent to determine if Dr. Heath and Dr. Lopez are correct, and provide the reason behind why you determined that Dr. Heath and Lopez are correct or incorrect in saying that their antivenom is just as effective as the other team's antivenom. You will use a standard answering process. You will use A, computation, okay, which is not very much here at a certain level. And then B, your answer sentence, which also will include your reasoning. And then C, name the numbers, but when you create your table of values, that will satisfy the name the numbers. And then your strategy that you're going to use to go ahead and get the correct answer. You will not use notes. We'll also take care of these questions right here as well. But first, let's talk about the first part of the challenge. So background music. So you'll see I already have 2 tables set up. One is for Dr. Lopez and Heath, and one is for the other team. So I have X for the dioxin, I have Y for the water. Well, it said 1/4 grams of dioxin, got that. And then it said for 1 gram of water. So what I need to do is I need to figure out if this truly is the same for both of them. Is it the same? Is it true that Dr. Heath and Dr. Lopez's antivenom is just as effective as the other team? So what I'm going to do is I'm going to go ahead and have a set of different ratios that I'm going to lay out to see if I can find that that's true or not. So I'll go over here. You see I have my first original, so the original ratio here. And over here there is a pattern that's happening, okay? And this pattern that you can see here is that this is increasing by 1/4 every time. So our original is 1/4 here, and then you can see 1/4 added on to 1/4 gets you 2/4. If I take 2/4 and add on an additional 1/4, I have 3/4. And if I take on another 1/4 and add on to the 3/4, I have 4/4. Another way to look at this is you can see this multiplication. So notice, one set of 1/4 is 1/4. 2 sets of 1/4 is 2/4. Well, how do I get that? So you might be slightly confused. How did I get 2 times that to equal? So I have 2 times 1/4. Take that. That's going to be 2 over 1 times 1 over 4. Final answer going to be 2 over 4. So notice how we got 2 over 4 there. Let's go ahead and let me get my little... So let's erase this here. Well then, how'd you get 3 over 4? It's the same way here. Let's run it one more time. So I have 3 times the original ratio, or the original part of the ratio, 1/4 here, which gives me 3 over 1 times 1 over 4, which equals 3 over 4. So that's how we're getting that. And once again, I would do 4 times this. So notice, there are 2 ways that you could describe what's happening here. You could say that you're taking the original fraction here and you're adding on that same value every time to the next amount. in a pattern. So I have 1/4 here, I add on 1/4 to it, I have 2/4. I have 2/4 here, I add on 1/4, I have 3/4. I have 3/4, I add on 1/4, I have 4/4. So notice that pattern there. You can also, you're increasing by 1/4, but you can decrease by 1/4. Notice if I'm at 4/4, if I go back 1/4, I'm at 3/4. If I go back 1/4, I'm at 2/4. If I go back 1/4, I'm at 1/4. So what's happening here is I'm getting a pattern of this increasing by 1/4 every time. So that's one way. Another way you can see is that I'm multiplying. So I'm taking the original value here from the whole ratio, this original value for the dioxin, and I'm multiplying it by 2. Okay, then I'm multiplying it by 3, then I'm multiplying by 4 like I showed you. Well, we're going to repeat that same pattern on the other side over here. Times 1, times 2, times 3, times 4. This also answers one of your questions, so let's take a look here. It answers one of the questions here. So it says, describe mathematical pattern that's happened on the right hand column of Dr. Heath and Dr. Lopez chart. What's the pattern here? I remember if you're doing addition, you're saying you're taking the original value and adding it on to every number, that new number that's created in the pattern. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 3 plus 1, 4. So that's what's happening there. Or you could say that you're multiplying, and I'll use the same thing over here. So if you're multiplying by 2 the original value here. You're multiplying the original value by 3. You're multiplying the original value by 4. And you can use the same thing on either side to get the same answer. Does this work on this side as well? Of course it does. The same thing that's happening over here. So 1 times 1, 2 times the original 1, 3 times the original 1, 4 times the original 1, 1 times the original 4, 2 times the original 4, 3 times the original 4, 4 times the original 4. So we have these patterns here. So let's see what I've answered so far. It looks like I've taken care of the computation part because I've laid out the tables with the values. And then I've also did the labeling, dioxin, water for the values, Dr. Lopez and Heath and the other team. What was my next challenge here? It said provide an answer sentence. So let's go ahead and get an answer sentence here. Now the answer sentence says that I must not only say if they're correct by what they're saying, but I also must provide some reasoning. So let's move this aside for a second. First thing I'm going to say is that yes, Dr. Lopez and Dr. Heath are correct. Alright, so they're correct. So now that we know that, let's talk about our reasoning. And our reasoning is going to send us to this table of values again. So let's go here. So there's 2 ways that you could prove that the good doctor was being truthful here. Let's erase this. So I'm going to erase this here. And we could go ahead and let's see. So let's go ahead and take a look here. I could do one way where I could divide. So I'll take the quotient. I'll find the quotient of every ratio. All right. So let's find the quotient of every ratio for this table here. Let's find the quotient of every ratio in that table over here. So I'll call this one the A table, and I'll call this one the B table. So we'll go over here, and let's go ahead and start finding some quotients. So the first one, remember our rule of y divided by x. I have 1/4 divided into 1. So let's do the math on that. A. B, I'll go over here, I'll put 1 over 1. Why? Because if I want to go ahead and make 1 a fraction, 1, 1. Notice if I wind up, it turns right back into the 1. So that's why we have 1 over 1 there. Let's go over here. I'm going to skip applying the reciprocal, putting the traditional division, and just go ahead and apply the reciprocal. So taking this fraction number here in the denominator, flipping it over, 4 over 1. And then see, let's go here, go there. 1 set of 4, 4. 1 set of 1, 1. Wind up. 4 for that one. Okay. Looks like it's 4 for that one. Let's go to the next one. So I'm going to erase some of this so I can get some space. I'm trying to keep this one near here. So we'll go here. Take a look at the next one. I have 2 divided by, what is that? 2 over 4. Alright. So let's go to the next one in the series. We'll call it B. So then B here. Let's say A for everyone. So A here, then B to go down. So I have 2 over 1. I'm going to apply the reciprocal. So then I have 4 over 2. I go over here, straighten out my line. 2 sets of 4, 8. 1 set of 2, 2. We could simplify. That will give us, what is that, 4 over 1. And then, of course, wind up, final answer, 4. So far we're getting 4, 4, 4. So I'm going to erase this, knowing that we have a pattern of 4, 4, 4. So every quotient so far has been 4. Let's go here. Let's go on to the next one. So then we have 3 divided by 3/4, and that's from the table of values. So I'm going to go A again. Go here. B. 3 over 1. Now I'm going to apply the reciprocal strategy. So then 4 over 3 dot dot, and then go here. C. 3 sets of 4, 12. 1 set of 3, 3. Wind up, or I could simplify, remember, so I can simplify, that would give me 4 over 1. Wind up gives me 4. Or if I don't want to simplify and just want to do the wind up, how many sets of 3 are there in 4? Excuse me, how many sets of 3 are there in 12? There are 4. Okay, so 4 again. So let's take a look at the last one. I have 4 divided by 4 over 4. Well, we could cheat a little bit here. We could go 4 divided by 1, because wind up, 1. We go over here, answer. So I don't know which way, maybe I'll go A, whatever. So we'll go here. And B is our answer, wind up, and I have 4. So it looks like all the quotients for Dr. Heath and Dr. Lopez are 4. Let's see what happens on the other side. Oh, man. All right. So the other team of doctors, y divided by x. So then I have 4 divided by 1, answer 4 from the wind up. Take a look at the next one. Next one I have 8 divided by 2, wind up, answer 4. Okay, let's go to the next one. I have, let's block that off, 12 divided by 3, wind up, 4. Then I have the next one here. I have 16 divided by 4. That gives me 4. And of course I could simplify the heck out of many of these all. And that gives me 4 over 1. I could go here, divide by 3, divide by 3. So for those you guys that want to do the smart cut and do that, you get the same answer. As well here, wind up. So you can apply the smart cuts. So notice that I can prove that they both have the same, that the antivenom that Dr. Heath and Dr. Lopez created is just as effective as the other one. How? By showing that I have a consistent rate of change, and that rate of change was 4. All right, let's talk about another way if you don't want to go through all that work. If you notice here, it says 1/4 to 1. What I can do is I can lay out a number line, and this also explains another question. So let me lay out a number line here. And notice 1-dioxin. There we have it. So we'll go over here. 1-dioxin. And that's for the other team. So let's say other team. Now, well, how many dioxins does Dr. Heath and Dr. Lopez have for this for this ratio compared to theirs? They have 1/4. So we'll go here. All right. 0/4. Hey, 1/4. 2/4. 3/4, and of course 1 is 4/4. So if we shade in here, we recognize that, hey, that's 1/4. That's Dr. Lopez and Heath. Okay, Dr. Lopez and Heath there. Well, that's 1. Well, then how many will it take to fill in the 1 of the dioxin? So it looks like 1 set, a second set, which gives me 2/4, a third set, which gives me 3/4, and then 4 sets. So if we look at that here in the chart, we go down 4/4 equals 1. 1/4. Where are we seeing that? 1/4. We have a big time equivalent ratio right here because it's the same. 4/4, which is 1/4. There we go right there. 1/4. So we have it laid out. That's another way. Equivalent ratio. Notice here 1/4, 1/4 in this situation. All right. That provided quite a few answers here. So I said for number 1, Dr. Heath and Dr. Lopez antivenom antidote is what size in relation to the size of the other team's antivenom antidote? 1/4 of the size, because see how many pieces I had to chop this into? I've only got 1 of them. It's 1/4 of the size. The other team's antivenom is what size in relation? This is mine. It's 1, 2, 3. It's 4 times greater. So notice, for number 1, our antivenom, Dr. Heath and Dr. Lopez, 1/4 the size of the other teams. The other teams is 4 times larger than ours. For number 3, we talked about the patterns on the left hand and the right hand side of Dr. Heath and Dr. Lopez chart. You're going to do the same thing for the other team down here in 5 and 6 as well. So this has been some tips to help you up for the assessment tomorrow. Make sure you look this video over if you have any questions, and good luck.